Okay, so we've discussed why OSS BSS are needed, and we've discussed who uses them. But what are they, and what functions do they perform? So let's tackle the first question first. What are they? OSS and BSS are applications that run on computer devices, which could include servers, cloud-hosted machines, personal computers, tablets, or even smartphones. Generally speaking, though, they handle such large volumes of transactions that they tend to run on powerful computing platforms like servers or on the cloud. However, you could also argue that they're more than just applications. They're called operations and business support systems because it's the combination of applications, data, the compute power, and the people and process wrapper around it all that makes them what they are. It's this overall solution that allows an operator to operationalize its network. They coordinate the many human, physical, and virtual resources that allow customers to utilize the network and deliver the revenue required to run these sophisticated organizations. Now, coming on to the second question, what functions do they perform? Well, a lot. As we mentioned earlier, many telcos have hundreds of different applications in their OSS and BSS stack. TM Forum, one of the most important standard bodies in the OSS and BSS industry, has kindly developed a method for OSS and BSS functionality classification. It refers to it as the TAM, or the application map. The TAM is part of TM Forum's frameworks tools. So let's take a closer look at how the TM Forum has categorized the functional blocks that make up the TAM. Firstly, let's look at the verticals. So here we have the strategy, infrastructure, and product vertical, operation support and readiness, fulfillment, assurance, and billing and revenue management. Next, we take a closer look at the horizontals. First, we have the marketing and sales domain, next the product domain, next the customer domain, the service domain, and the resource domain. Added to that, we also have the supplier and partner domain and the enterprise domain. We also have these support functions that cross over all of these. But then we dive into level 2 functionality breakdowns, and this is where there are around 75 functional breakdowns. This is where things get interesting, as this is where we find the major functional blocks that OSS and BSS products tend to comprise of. We should also point out that these functions are not all necessarily provided by different applications. Some vendor products are able to perform one or more of the functions shown, and others only perform part of the function shown. Some telcos will need most, if not all, of these functions, yet no vendor that I'm aware of is able to supply every application shown on this chart. This means that significant integration effort is required to make all of these functions work seamlessly. TM Forum is also embarking on a journey to standardize these integrations via its Open API project. But when we talk about OSS BSS for smaller carriers, internet service providers, utilities, or enterprise customers, there's a need for a smaller application footprint and the corresponding budget. As such, I tend to use my own clumping of functionality to represent some of the key product categories available on the market for these mid-tier customers. These classifications shown in blue aren't part of TM Forum's TAM classification officially, but I do find them helpful for categorizing the more than 400 vendors that appear in the Passionate About OSS Blue Book of OSS and BSS vendors that you'll find in the link shown below. Now, let's consider how an end-to-end journey might flow through these functions. Let's use the example of an O to A, or order to activate. Depending on the service type, it might travel across functionality spread across 1, 2, 4, 5, 7, 14, 13, 9, 10, 12. Actually, there's a better framework for designing process flows, also kindly provided by TM Forum, which is called the ETOM, or, in other words, the Enhanced Telecommunications Operations Map. ETOM is also part of the framework suite of recommendations, but we'll use the TAM as a proxy because we already have it on screen and showing some of the functionality. We also need to consider how point-to-point-to-point data flows may occur across these journeys. Perhaps across interfaces between functional blocks, or perhaps also via a common data store, or perhaps even via a messaging bus to distribute between the various components. But let's pause here for a moment. You should have spotted within that flow that I just described that it was only for a single customer journey as it hopped from point to point to point through these blue boxes. That's only a single customer activation of an O2A service. So consider or imagine trying to coordinate that when your network supports millions of subscribers at various different stages in a customer lifecycle. For those really large networks and customer bases, there are many thousands of these journeys underway at any single point in time. Some steps are automated, some are manual. Some steps are almost immediate. Others, like when new physical build is required, can take months to proceed. Can you imagine juggling all of those balls simultaneously across different applications, different users, different service types, different jurisdictions, and constraints such as resource availability? Then throw in factors like approval processes, geographies, workforce sequencing, skills availability, resource outages, and so much more. Is this giving you a sense of why OSS and BSS are so important to modern network operators? Are you also getting the sense of how sophisticated these solutions need to be to know what's going on at such a massive scale? And then also be sophisticated enough to accommodate all of the variables as they change from minute to minute. If a device in the network fails, or a field worker misses a customer appointment, the OSS and BSS need to know so that they can take the appropriate action.